Okay, so this is where I left off. So this is page 3, number 56 from this. And, okay, so it's this problem here. So they're asking you to do what? Okay, these are the directions. So find the slope of the tangent line to the graph, write an equation for this tangent line. Okay, so all that the test is going to be is like this part. I'm just going to say, write an equation for the tangent line to the graph of, some equation at a certain point, okay? And I may or may not give you the graph of it. So what we need to do, so I drew the tangent line, so we're writing the equation of this line. And in order to write the equation of a line, you only need two things. The point of tangency, or the equation of a tangent line, the point of tangency, and then the slope. And what is the slope of a tangent line? It is the derivative. So I go over here. All right, so I want the point of tangency, and then I want the slope, which is y prime, at the point of tangency. So it's going to be y prime at 1, -3 is what I want. So the point of tangency they have given me. And now to find the slope, I need y prime. So I take this equation, this original, and we have to do what's called implicit differentiation. So differentiation means to take the derivative. And when you take the derivative implicitly, that is just a way of saying to do, do the derivative when you have like dx dx at the end and then dy dx at the end. But I'm gonna just jump right to the y prime stuff. Sorry if I'm not making sense. So, okay, the derivative of this term is 2y, but then you need dy dx, so y prime. The derivative of this term is minus 6x, but then you need dx dx, which is just 1, so I don't even bother. And then the derivative of that is 0. Okay, now I need y prime at this point here. Now you could solve for y prime at this moment and then plug in the coordinates, or you could just plug in the coordinates right away, which is what I like to do. So I'm plugging in for y, -3. I'm plugging in for x, 1. So then you have -6 y prime minus 6 equals 0. So -6 y prime equals 6. So y prime is -1. So that is the slope that we're going to use. And then you plug into the point slope formula. Okay, so in for y1 goes -3. In for the slope goes -1. And then 1 goes in there. And this is y plus 3 equals negative x minus 1. And you could just leave it like that. Okay. If they ask you to graph it, then you'd want to solve for y and stuff, but you could just leave it like that. Okay, so that topic was finding the equation of a tangent line at a given point. Now this is the last one. Finding locations of vertical and horizontal tangent lines. You're going to see one problem with that. Okay, so let me do this. So this is from page 4, and it's number 72. All right. Tangent line to a lemniscate. Okay, so I guess this is a lemniscate. So the graph of this is called a lemniscate, is shown in the figure below. There are exactly 4 points at which the tangent line to the lemniscate is horizontal. Find them. Oh, okay. So those would be, like right here we'd have a horizontal tangent, here we would, and there we would. So there you can kind of see where these 4 points are going to be. So just being able to visualize where they are will help you know if your solution makes sense or not. So, but guys, for on the test, I could also ask you to find the points at which the tangent line is vertical. Okay, so on test, I could also ask for points where tan line is vertical. And then if you look here, you see that there's going to be 2 points. Oh my gosh, and you could actually, like, looks like it's going to be right at those, at 1 and -1. Okay, but now for the problem. So we have to find the derivative of every term. Okay, so we have to have the derivative of that, the derivative of that, and the derivative of that. Now for this one, we need chain rule. Okay, this is 2x dx dx, which is just 1, plus 2y dy dx, which is y prime. And then make sure that goes in parentheses. And then this is just 2 blank. And then x squared plus y squared goes back in. Okay, so it ends up being, so this is the derivative of this part. And then this is equal to, so 2x dx dx, which is just 1, minus 2y dy dx, which is y prime. Okay. And now, oh, this is messy. I've got to, all right, so here's the thing, guys. So a horizontal, all right, so horizontal tangent, or yeah, horizontal tangent, then m equals 0, so the slope is 0, which means y prime is 0. So I've got to figure out the points at which y prime is 0. And I haven't done this yet, so I hope it works out nice. So what I need to do here, there's like a lot of algebra in these problems. So I've got to distribute this to those. I think that that would make it work nicer. So this is going to be 4x x squared plus y squared plus 4y x squared plus y squared times y prime equals, okay, now this is a y prime term and this is a y prime term, so I need those to be on the same side of the equation so I could factor out the y prime, and then I need the other stuff on the other side. So then, all right, so how will this be? This will be 4y x squared plus y squared y prime plus 2y y prime equals 2x, and then I want this one over there, minus 4x x squared plus y squared. And then I factor out a y prime over here, plus 2y. Okay. And then I divide both sides by that. So, yikes. So we get, oh my gosh, 2x minus 4x, x squared plus y squared over 4yx squared plus y squared. Okay, so I'm looking for the location of a horizontal tangent. So, all right, so this is what I want. So I've got to figure out where y prime is 0. So now I take y prime, 2x minus 4x. Okay, how about I just say this? Equals 0 when numerator equals 0. So a fraction equals 0 when its numerator equals 0. It's undefined when its denominator equals 0. So I'm just taking the numerator and setting it equal to 0. Alrighty, now here is the problem. 2 variables. Okay, so 2 variables. So need second equation. If you have 2 variables, you need 2 equations. And guys, at this point, you can use the original. So the original lemniscate, I've never even heard of that before, equation is this. All right, and this is a complicated system of equations, but it is a system of equations. So you've got, this is equation 1, this is equation 2. And you've got to solve for one variable in one equation and then plug it into the other. So this is complicated, but I look here and, shoot, crap. Yuck. Yikes. Okay, I guess it probably makes the most sense to solve for y here and then plug it in there. The one on the test will not be this hard, I promise. All right, let me distribute the 4x. So this is 2x, yeah, 2x minus 4x cubed minus 4xy squared equals 0. Okay, so let me solve for y. And then, so I get negative 4x y squared equals negative 2x plus 4x to the third. So y squared is equal to negative 2x plus 4x to the third all over negative 4x. Okay. Oh, perfect. All right. Now, instead of, this is kind of tricky. Instead of solving for y and then plugging y in, you could just plug in for these y squareds. So this is kind of heavy algebra. Because you solved for y squared. This is y squared. So wherever you see a y squared up here, you can just plug in this. So this becomes, all right, so plugging in there becomes x squared plus, okay, this whole thing is going in for y squared. So negative 2x plus 4x to the third over negative 4x squared equals x squared minus plus 4x to the third over negative 4x. Oh my gosh. Oh, okay, this will actually be kind of nice, I think. Alrighty, now I have to simplify what I can. Alright, so this is x squared, and then this is plus, this just ends up being a half. Okay, so I'm like splitting up this fraction. Okay, so like this part just becomes a half. This part becomes, oh, thank goodness, minus x squared. And if that doesn't make sense to you guys, you should pause and try to figure that out. All right, so this becomes 1/2 minus x squared, thank goodness, equals, oh, same thing, right? X squared minus, because this is the same thing, minus x squared. Oh, good, this is turning out nice, actually. These are canceling, so this is just a 1/2 squared equals x squared minus a 1/2 plus x squared. Sweet. And then that'll be 2x squareds. So that'll be 2x squareds. All right, so this is a 4th equals 2x squareds minus a 1/2. Okay, let me grab another paper. And then, so this is 2x squareds. I have to add a 1/2 to both sides. Equals, so 1/4 plus a 1/2 is 2/4. So 1/4 plus 2/4 is 3/4. And then you divide by 2. X squared equals 3/8. And then x is, oh my gosh, plus or minus radical 3/8. Okay, so over here, so this number, shoot, that doesn't seem to make sense. Oh yeah, because that's 0.5. This must be, yeah, that's 0.5. So this right here, that must be radical 3/8. Radical. Okay, good, which is about 0.6. Okay, so yeah, so this x-coordinate is radical 3/8. This x-coordinate is negative radical 3/8. But then both of these have these two y-coordinates, which we've got to find. All right, so, all right, so x is plus or minus that. And then to find y, you could just plug in to this one. Like right here, you know what y squared is. I know this is tricky, guys, but this is just heavy algebra at this point. It won't be like this on the test. Okay, so negative 2 radical 3/8 plus 4 radical 3/8 to the third over negative 4 radical 3/8. Okay, so I'm plugging this all into my calculator. Oh my gosh. Actually, you know what? Okay, it's honestly probably easier just to leave it like that. And then, so you'll say that y is equal to plus or minus radical, and then all of that. Okay, so negative 2 radical 3/8 plus 4. Oh my gosh, okay. And then, okay, so for, all right. And then you could really do this, and then I'll be like, let big, ugly, radical equal capital A. Okay, so this is y equals plus or minus capital A. So these 2 points, so the 2 points that correspond to the x value radical 3/8, which is right here, so these two y coordinates, so this one is radical 3/8 comma positive a, and then this one down here is radical 3/8 comma negative a. All right, so those would be two of the things. So radical 3/8 a, and that's totally legal, guys, what I did, like letting it be a, so you don't have to write it over and over. But then we're also going to have the 2 points for the negative. Okay, so the 2 points for the negative one, and you know what, I could actually see that it's symmetric, that these are just like a reflection of these, you know, like to get, I'm going to kind of do a shortcut here. So for this, I just reflect it over the x-axis, and then for this, I just reflect it over the x-axis. So I guess I'd end up getting, actually, let me not cut corners there. Okay, so, all right, so we're gonna have the same thing. All right, so this is for x equals radical 3/8 positive. And then maybe over here I'll be like, for x equals negative radical 3/8, y equals plus or minus -2 negative radical 3/8 plus 4 negative radical 3/8 to the third over -4 negative. Okay. And then I'll say let radical equal b, so we get that y is plus or minus b, which I bet you that this is the same as a, honestly. I think it's the same, because I think the negatives would just end up like canceling. But I'm just being safe in case it's not symmetric, but I'm like sure it is. And then so this would be, all right, so this is radical 3/8 b, radical 3/8 negative b, which I'm pretty sure is the same as a, but you really can't assume that, I guess. So this is b and negative b. Holy crap. It will not be that hard, guys. So for the test, you really just need to know that for a horizontal tangent, the slope is 0, so the derivative is 0. And then if it's a vertical tangent, suppose I asked you for a vertical tangent, then m would be undefined, which means that y prime is undefined. And then you would do very similar work, but instead of the numerator, you would set the denominator equal to 0, okay? I won't ask you both. I won't say find all locations of all vertical and horizontal. I won't ask you both. I'll just ask you either find the points where a tangent line is vertical, or I'll ask you find the points where the tangent line is horizontal. Okay, I won't ask you all of them. And this lemniscate thing, this is in the very back of a homework. This is in like the very back of a chapter review, so this was meant to be a challenging problem. It was meant to be challenging. It's nothing I would put on a test. The algebra is too heavy. But the calculus isn't that bad. But the algebra is just too heavy for a test. Okay, guys, I hope that that was helpful. I hope anyway you got like the idea behind doing a problem like that. You know, getting the derivative, you know, etc. Okay, I will see you later. Bye-bye.